Welcome to CodeCradle. Today we are going to learn microservices interview questions part 2. What is synchronous and asynchronous communication? Synchronous communication is like having a conversation on the phone. We talk, then the other person immediately responds while both of we are connected. Asynchronous communication is like sending an email. We send a message and the other person can reply whenever they have time, without both needing to be present at the same moment. In software, synchronous means waiting for a task to finish before starting another, while asynchronous allows tasks to run in the background, letting we do multiple things at once. Can you explain the role of message brokers in microservices? In microservices, message brokers help different parts of an application talk to each other without being directly connected. They act like mail carriers, picking up messages from one service and delivering them to another. This helps to keep the services independent and improves the system's ability to handle more users or tasks smoothly. Message brokers manage the queuing, routing and safe delivery of the messages, making communication more reliable and efficient. What are some of the risks involved with inter-service communication? When different services in a microservice architecture talk to each other, there are a few risks. Network problems can slow down the communication or cause messages to get lost, which can mess up how the application works. Managing many services talking to each other can also lead to mistakes or inconsistent data if they are not perfectly synchronized. Each service is also a potential weak spot for security. If one service has a security issue, it could affect the whole system. Lastly, relying heavily on a network communication can make it tough to find and fix problems when they happen. What is a service registry? Service registry in microservices is like a phone book for services. It lists all the services in the system, where they are and whether they are available to use. When a service starts it adds up itself to the list. Other services check this list to find and connect with the services they need. This setup helps to manage traffic effectively, balance the workload and adjust to changes such as when services are added or removed. How does service discovery work in microservices? Service discovery in microservices helps to services find and talk to each other. When a service starts up, it tells a central service registry where it is and how to connect it. When one service needs to communicate with another, it checks this registry to find the most current information on where and how to connect to the other service. This system makes sure that services can always find each other even as they change or move around within the network. What would happen if a service registry fails? If a service registry fails, it can cause big problems in a microservices because services use the registry to find and connect with each other. Without the registry, services might not be able to locate the ones they need, leading to failures in a processing request. This could make parts of the application stop working. To prevent such issues, systems often have backup registries and setup that ensure the registry is always available if one part is fails. How do microservices update their registration and discovery information? In microservices, services keep their registration and discovery information up to date by regularly checking in with the service registry. When a service starts or changes, it updates its details in the service registry. It also sends frequent heartbeat signals to show it's still running. If the registry stops getting these signals, it thinks the service has stopped working and removes it from the list. So other services don't try to connect to something that is not there. This keeps the system information accurate and reliable. How do you handle data consistency in the microservices? In microservices, keeping data consistent involves a few strategies. One common approach is using events to update data across services slowly but reliably. This is called a eventual consistency. Another method is a saga pattern, where a series of steps or transactions are performed across different services to complete a larger process. These methods help to ensure that even though services are separate, The data across them remains accurate and consistent. What is eventual consistency? Eventual consistency is a concept used when managing data across different locations in a network. It means that when the data is updated in one place, it might take some time before all parts of the system see the change. This approach allows the system to run faster and handle more users or actions at once. Even though the data might not be exactly the same everywhere right away, eventually all parts of the system will have updated.